Hello everyone. In this video, we shall discuss inequalities, properties of inequalities, and the interval notation. So what are inequalities? Inequalities are mathematical statements that tell us that two quantities may or may not be equal. Inequalities make use of the symbols greater than, less than, greater than or equal, or the less than or equal symbol. Now, there are several properties of inequality. So let us let first A, B, and C to be elements of the real number system. Now, the first property of inequality is the trichotomy property. The trichotomy property states that A could be greater than B, or A could be less than B, or A could be equal to B. So only one of this is actually true. So for example, if A is equal to 5 and B is equal to 3, then we can say that 5 is greater than 3. So that means A is greater than B is true, while A is less than B and A is equal to B are both false. Now, if A is equal to 2 and B is equal to 5, that means 2 is less than 5, so only A is less than B is true, and then A is greater than B and A equals B are false. Now, if A is equal to 3 and B is equal to 3, then that means A equals B is true, while both A is greater than B and A is less than B are false. Now, the second property of inequality is the symmetric property of inequality. So if A is greater than B, then we say that B is less than A. Third one is the transitive property of inequality. And this states that if A is greater than B and B is greater than C, then definitely A is greater than C. Now, alternatively, we have if A is less than B and B is less than C, then A is definitely less than C. And then for the addition property of inequality, if A is greater than B, then if we add the same quantity to both sides of the inequality, then A plus C is still greater than B plus C. Or alternatively, if A is less than B, then A plus C is less than B plus C. Okay, and then fifth, we have the multiplication property of inequality. And this states that if A is greater than B and C is positive, then if we multiply both sides of this inequality by a positive number, then A times C is still greater than B times C. Now, alternatively, if is less than B and C is positive, then A times C is also less than B times C. Now, however, if A is greater than B and C is negative, if we multiply both sides of the inequality by a negative number, then that means A times C is less than B times C. So in effect, multiplying by a negative number to both sides of the inequality will reverse the inequality. And also, if A is less than B and C is negative, then A times C would be greater than B times C. So the fifth property of inequality is actually important whenever we're solving for different types of inequalities like linear inequalities and quadratic inequalities. And then for the interval notation, let's consider the following. Okay, so let's consider x is less than 2. So graphically, x is less than 2 is represented by a single number line, and then we're going to plot 2 anywhere on this number line. And then this tells us that all the values or all the real numbers that are less than 2 would satisfy this inequality. So which means, so since 2 is not included because there's no equality symbol here, then graphically it will be represented by a hollow point. And then everything to the left of 2 are solutions of this inequality. Now the interval notation, the leftmost part of the number line is negative infinity and the rightmost part is positive infinity. So to write this in interval notation, we will read the graph from left to right. So we begin with negative infinity and we end at positive 2. Now, negative infinity is always preceded by a parenthesis, and then the 2, since 2 is not included, it will be followed by a parenthesis. So this is the interval notation for x is less than 2. Now, if we have x is less than or equal to 2, then graphically, x equals 2 is included, so it will be represented by a solid point, and then everything on the left side of 2 are part of the solution. So which means in the interval notation, this will be read from left to right, so that's negative infinity, and we end at 2. As I said earlier, negative infinity is preceded by a parenthesis, while since x equals 2 is included in the solution, then it will be followed by a bracket symbol. Now for x is greater than 2, graphically, we plot 2 anywhere on the graph, and then since 2 is not included because of the absence of the equal sign, then 2 is represented by a hollow point, and everything on the right side are solutions of this inequality. So when we read the graph from left to right, we start at 2, and then we end at positive infinity. Since 2 is not included, it will be preceded by a parenthesis, and positive infinity is always followed by a parenthesis. And then if we put an equal sign, so graphically, 2 is included, it will be represented by a solid point, and then everything on the right side are solutions of the inequality. So reading the graph from left to right, we start at 2 and end at positive infinity. So since 2 is included, 2 will be preceded by a bracket symbol, while positive infinity is always followed by a parenthesis. Now, if we have the inequality, let's say negative 3 is less than or equal to x is less than or equal to positive 2. So graphically, we plot negative 3 first, and then positive 2 is to the right side of negative 3. So this means that both negative 3 and positive 2 are included because of the presence of the equal sign. So both of them will be represented by a solid point. And then everything in between are solutions of this inequality. So if we read the graph from left to right, now we're going to start with negative 3 and end at positive 2. And then since both of them are included, then negative 3 is preceded by a bracket symbol, and positive 2 is followed by a bracket symbol. Now, if we remove one of the equal signs from that inequality, then that means negative 3 here, since there's an absence of the equal sign, so negative 3 is not included, but positive 2 is included because of the presence of the equal sign. And then everything in between them are solutions of this inequality. So the interval notation for this inequality is negative 3 comma 2, negative 3 preceded by a parenthesis because it's not included, and positive 2 is followed by a bracket symbol. Now also, if we have negative 3 is less than or equal to x, but is less than 2, so similarly, we plot negative 3 and positive 2, but negative 3 is included, positive 2 is not included, but everything in between them are included. So the interval notation here will be -3 comma 2. -3 is included, but +2 is not included. And then whenever we have -3 is less than x is less than +2, then this means that both -3 and +2 are not included, but everything in between them are solutions of the inequality. So in interval notation, that will be written as -3 comma 2, but both of them are not included. So that means one is preceded by a parenthesis and the other one is followed by a parenthesis. Now, if we have something like x is greater than or equal to +4, and then let's say we have n, x is less than 7. So how are we going to graph the following inequalities? So on the number line, we're going to plot +4, and then +7 is positioned to the right of +4. Now, if we graph x is greater than or equal to -4, that would mean the 4 is included in everything to its right side. While for x is less than 7, that would mean that 7 is not included, but everything on the left side of 7 are included. However, the end here indicates that we need to get the intersection of the following solutions. So, or the intersection of the red and the yellow direction. So in this case, 4 is part of the intersection, but 7 is not part of the intersection because it's a hollow point on the yellow line. So it will be represented by a hollow point. And then everything in between them are part of the solution. So which means that our interval notation will begin with 4 and then will end with 7. 4 is included, but 7 is not included. Okay, and then if we have, let's say, x is greater than or equal to -1, and x is greater than or equal to 3. And so again, on the number line, we're going to plot -1, and then +3 is positioned to the right of -1. So to solve for x is greater than or equal to -1, -1 is included, and everything to its right. And then x is greater than or equal to 3 means that 3 is included and everything on its right. So if we get the intersection would be x equals 3 and then everything to the right side of 3. So which means that in interval notation format, this is written as 3 comma up to positive infinity. 3 is included, so it will be preceded by a bracket symbol, and the positive infinity will be followed by a parenthesis. Okay. And then if we have, let's say, x is less than 1, or shall we say x is less than or equal to 1, and let's say x is greater than 5. Okay, so graphically, we plot x equals 1, and then x equals 5 is positioned to the right side of 1. Now, x is less than or equal to 1 means that 1 is included in everything on its left. And then x is greater than 5, that means 5 is not included, but everything on its right are included. But since we're using the end notation, and the red line and the yellow line do not have a common interval intersection, then that means that this thing is an empty set. So there's no intersection. Okay, now if we have the following, let's say x is greater than or equal to -1, or x is greater than or equal to 3. So how are we going to interpret this in interval notation? So graphically, we plot -1 and then +3 is to its right. X is greater than or equal to -1, is represented by a point on -1 and everything to its right. And then x is greater than or equal to 3 is represented by a point on x equals 3 and everything to its right. Now, when we say or, we're getting the union of the red and the yellow um, lines. So that means the or here means it's the union, so which means we're considering everything starting from -1 going to the right side. So that means the solution set here would be we start with -1. -1 is included, so it will be preceded by a bracket symbol, and then it will end to positive infinity. Now, if we replace this thing here by an or, then that means the solution for the following inequalities would be from -infinity up to 1, and then 5 up to positive infinity. So let's write it down. So if we have x is, let's say, less than or equal to 1, or x is greater than 5, then that means 1 is plotted here, and then 5 is to the right of 1, and then 1 is included and everything to its left. And for x is greater than 5, 5 is not included, but everything on its right are included. But since we're looking at an or statement here, that means that the solution here would be from -infinity up to 1. -infinity is preceded by a parenthesis. 1 is followed by a bracket symbol. And then union 5 up to positive infinity, and then 5 is preceded by a parenthesis, and infinity is always followed by a parenthesis. Okay. Now, if we have, let's say, x is less than or equal to 5, or x is greater than or equal to 1. So for this particular um, inequality, we plot 1 first, and then 5 is to its right. X is less than or equal to 5 means that we start at 5 and we consider everything to its left. And then x is greater than or equal to 1 means that we consider 1. 1 is included and everything to its right. But since we're looking at an or statement here, then we're getting the union of um, the red and the yellow lines. So the union would be the whole number line. So which means it's -infinity up to positive infinity. So this ends the video about inequalities, properties of inequalities, and the interval notation. So all of these are significant in solving for linear inequalities and quadratic inequalities, which you will encounter in the succeeding videos. So thank you for listening, and I hope that you can subscribe to my YouTube channel. Thank you.